right, so continuing with glomerular filtration rate, the controls. We just talked about the myogenic control, which is instantaneous. And now we're going to talk about the juxtaglomerular control of this. So this is going to involve the juxtaglomerular apparatus. So if you remember, the apparatus were these macula densa cells. So macula densa cells and the juxtaglomerular cells. Okay, so those macula densa cells we said before they monitor the filtrate. And remember, filtrate is not urine, it's pre-pee basically. So they monitor the filtrate mainly for sodium. Okay? And if they perceive that the condition of that filtrate, if the filtrate shows that blood pressure is low, and that comes from the osmolarity. So if there's a lot of sodium in the filtrate, that means it's not in the blood. So that's going to indicate that blood pressure is low, because sodium itself is a solute, an ion, and as it's leaving, water's leaving too, right? Water follows the solute. So that's going to basically indicate low blood pressure. So when that happens, when low blood pressure is sensed by the macula densa cells, then they signal, so macula densa cells signal the juxtaglomerular cells to secrete something called, I'm going to put it in a different color, just renin. And renin is a substance that when it goes into the blood, and remember that's what's happening because the juxtaglomerular cells are here along the blood vessels here, so that means renin is going into the blood. And when it does that, renin itself is a chemical, sort of like a hormone. Okay, so it will signal, so renin will signal a plasma protein called angiotensinogen. Let's put that in red because it's in the blood. So angiotensinogen. This is a plasma protein. It's floating around the blood all the time. Okay, but it's not like active. Okay, so renin is what makes it active. And so when renin comes into contact with angiotensinogen, it becomes angiotensin 1. All right, angiotensin 1, so angiotensin 1, if it contacts a substance, which is an enzyme, so contacts an enzyme called ACE. If it contacts ACE, then it will become angiotensin II. All right. What in the world does angiotensin II do? Well, it does a lot of things. So angiotensin II will increase blood pressure. And it does that by causing vasoconstriction. All right. It increases thirst. And will also increase cardiac output. And as you remember, with cardiac output, that means there is going to be an increase in stroke volume and heart rate. Okay. So that, of course, will increase the blood pressure. This is going to be slower. Okay, anything that has to do with a chemical like a hormone is going to be a little bit slower. The myogenic response is immediate. Okay, but this is going to be slower but more powerful. And it's going to counter the body's blood pressure if it's going up so that it can maintain the proper glomerular filtration rate. Okay, so there's more to this story and it will continue a little bit later, but right now we're just talking about glomerular filtration rate, and that's going to have an effect on that. All right, so the next video we're going to move into the PCT, the proximal convoluted tubule, and what's going on there.